A2 in Advanced Algebra 2, and what we're doing is this chapter is all about factoring, and we're going backwards. Last time, one of our concepts was doing conjugates backwards, where, like in Chapter 7, we started with conjugates, and we helped multiply them together and got this. Then, what we did in Chapter 8 was that thing's called the difference of squares. To factor it, it's just conjugates backwards. That was one of our shortcuts. Wasn't there another shortcut for like something like this guy right here? He's called the binomial squared. And what we did was we squared the first guy, then we did twice the product, so wouldn't that be minus 4x, and then we squared the last guy on that guy. What we're going to do today is check to see if this thing, the first like 9 questions ask, is it a perfect square trinomial? Here's the interesting thing. You are trained very well on what some perfect squares are, you know, like 1 squared, 2 squared, 3 squared, but you just get numbers back all the time. A perfect square is actually anything that you took and squared it. So do you see how we took x minus 2 as an entire quantity and squared it right there? What did I get back? How many terms? 3. That's called a what? Monomial, binomial, or trinomial. What's that called? That's a trinomial. But he's also a perfect square because it is the results of something that got squared. So this first little check right here is they're asking, yo, bro, is this thing right here a perfect square trinomial? And it has 3 things to check. Just like back here, didn't you have to do 3 moves to get it? Are you with me? You had to do 3 moves to get it. There's 3 things to check. So here's what we'll do. First, we'll do the first step. Is the first term a perfect square? What do you think? X squared. Is that a perfect square? Yes, it is. Now I'm going to show you a little cheat code right here to determine this. Here's what I want to do. I'm going to write, if I say yes, right? If I say yes, let's write down the square root of him. Who is the square root of x squared? X. Are you with me on that? So just kind of in the process of determining, is this a perfect square trinomial, I passed step 1. Boom. The first guy was a perfect square, so I wrote down its square root. Then they say, is the last term a perfect square? Well, that would be this guy right here. Is 64 a perfect square? Yes or no? Yes. So we'll write down his square root, and that would be 8. Are you with me on that? And then we got to do a little bit of a cheat code. We got to sneak down this sign from the middle. Do you see in the middle, that is a subtraction sign, not a plus sign, right? So we're going to sneak that guy down right there. And then here's step 3. Is this middle term, let me get a little erasing going on right here, is this middle term twice the product of those square roots? So like, you see how I already wrote those square roots down? If I multiplied those together, wouldn't I get negative 8x, right? And then if I doubled it, I get negative 16x. Is that what this middle term is? Yes or no? Yes. There are 3 phases to be a perfect square trinomial. The first 2 phases are butter, right? Is this a perfect square and is this a perfect square? But it's that third phase where you have to do some little mental math to see if it really works. So the answer in this case was yes, right? So then they say, all right, we'll answer the question, by the way, yes, this is a perfect square trinomial. If you say yes, they ask us to factor it. Well, the cool thing is about my little cheat code is we are 99% done factoring that guy. It should factor to be this as a binomial being squared. Like, isn't that totally what is going to happen, right? If I gave you this quantity right here, and I said, hey, let's multiply this out, and I say square the first guy, would you get this right here? Would you get x squared? Then if you did twice the product, would you get negative 16x in the middle, right? And then if you squared the last guy, would you get 64 back for the third dude? We are undoing the binomial squared today, and that's called factoring a perfect square trinomial, which is kind of weird. So let's try again. This is a trinomial. They're asking us, hey, bro, is it a perfect square trinomial? How do you tell? 3-step process. Step 1, is the first term a perfect square? Yes. So when we say yes, we will take the square root. If that's a no, if it's not a perfect square, then we're done. The answer is no to this question. It is not a perfect square trinomial. But so far, we're at a yes. How about this? Is the last term a perfect square? What do you think? So we'll throw a 5. down. And then the secret is you got to snag the middle guy's sign, right? The middle guy's sign. Now, for phase 3, the work that we got to do, either mentally or in a calculator, is this guy right here in orange, twice the product of those dudes down there. What do you think? Yes or no? Yes. All 3 phases are passed, so this is a yes to that question. It is a perfect square trinomial. And then they say factor it. Sweet. I'm already done, because isn't it the binomial squared backwards in that case? So, neat. Let's try that again. Is this a perfect square trinomial? Phase 1, is p squared a perfect square? Yes. Put his square root down. Is the last guy a perfect square? Yes. Who is his square root? 8. Sneak down the sign from the middle. And now here's the test. Is this blue term twice the product of those 2 other guys? It is not. We have failed. Is this a perfect square trinomial? Yes or no? No. So then what we should do is just like cross that out. We were starting the factoring process, but it is not going to factor to be p plus 8 quantity squared. It's not going to work out. That turns out to be p squared plus 16p plus 64. Are you with me on that? So that is not a perfect square trinomial. Let's try again. On number 4, is the first term a perfect square? I mean, x squared is 2. Are there 2 numbers exactly the same that multiply together to be 2? They got to be whole numbers, by the way. It's like, well, if you do square root of 2 times square root of 2, yeah, but it's not like 1 times 1, and it's not 2 times 2, and it's not 3 times 3. Is 2 a perfect square? Nope. So is this a perfect square trinomial? Nope. We have failed. All right, you got to pass all 3 phases. I don't care which one fails, if it's the first one, the second one, or the third one. If any of them fail, you are answering no to these questions. So let's try again. Is the first term a perfect square? Yes, it is. So I will jot his square root down. Is the last term a perfect square? Yes, it is. Sneak down the sign from the middle and check to see if the middle guy is twice the product of the numbers we have written down already. What do you think? Yes. Is this a perfect square trinomial? Yes. Then factor him. And that's the fun part. Boop, boop, boop. All right, just throw the parentheses and the quantity squared down. Why is number 6 weird? Why is number 6 weird? Is it 3 terms? Yes or no? Yep, so it's a trinomial. Is it quadratic? Yes. Well, he's weird. Why is he weird? Yeah, it's out of order. It's not what's called in standard form. Doesn't it usually go the squared guy, then the first power guy, then the guy with no letter in him whatsoever? It doesn't matter, right? We could still we could rearrange him if we wanted to, or we could try it like this. Is that a perfect square? Yes or no? Is 81 a perfect square? Who's the square root of 81? 9. Is this a perfect square? J squared? Yep, so square root of him is j, sign from the middle. If I took twice the product of those 2 dudes that I have written down right there, would I get what's in the middle? Yep, so he's just weird, and I will say for future references, we won't write them down like that if we don't have to. I would rearrange that to be j squared plus 18j plus 81, because that's how math brains like to think about it. Cool. All right. Why don't you try 7 with a neighbor? See what you think. All right. What do you think about this guy? 16m squared. Is he a perfect square? Who's his square root? 4m. Cool. How about that guy? 36. Is he a perfect square? Yep. What's his square root? 6. And I'll sneak down this sign. If I multiply those together, I get 24m, right? I need 48m to be in the middle, right? Is 48m in the middle? Nope. This is just the product of those. It's supposed to be twice the product. It is not twice the product. So this is a big fat no, and we'll cross that guy out. Let's see what you think about 8. pause the video, and then we're going to take a vote here in class in about 45 seconds. So I'll give you 45 seconds to a minute to try 8. We did a little vote in class while we were paused there to see if this is a perfect square trinomial or not. I kind of hinted that it probably wasn't going to be, because I said we're going to vote. The answer is no. This is not a perfect square trinomial. But boy, is he tricky. Is this a perfect square? Yes or no? Yep, 5A. Is this a perfect square? I'm going to write down my list of perfect squares. 1 squared is 1. 2 squared is 3 squared is 9, 16, 25. I can go on for a while. Will -4 be on that list? 4 is a perfect square, but that number is -4. Are you with me on that? So that is a big fat no. The tricky optical illusion that they want to put a perfect square there with a negative. That homeboy right there has to be a positive boy for this to work every time. Cool? So this is a no, right? And then the last one we'll do together is b squared a perfect square? Pretty obvious, right? How about 256? You know how I have you memorize usually up to the first 15 perfect squares? Are there more than that? Isn't 15 squared 225? So I'm not asking you to have them memorized, like what 16 squared, 17 squared, 18 squared is. But you can tell in your calculator by taking the square root of that number. If I could get my calculator open, the square root of 256, does it come out to be an integer? What do you think? Yes or no? That came out real nice. So once you get bigger than 225, we can run to ye old calculator, and I would get a 16, and I did it wrong. What did I do wrong? Put the old plus on the middle when it's supposed to be a what? Minus. It's not that hard of a concept. It's just weird, right? And I want to be honest with you. This doesn't happen very often, right? It's like, not every trinomial in the world is a perfect square trinomial. But today, we are going to focus on, if we do have a perfect square trinomial, how could I deal with it? Were any of these equations? Yes or no? No equations. Are the rest of them equations? And they are very, very different. So here's the interesting thing about perfect square trinomials. We do not need them to be ready to run. What does ready to run mean again? The whole quadratic equation is equal to 0. We do not need that. Here's what I would like to do. I would just like to look to this thing right here, which is quadratic, right? Remember, it's quadratic. Hey, why not difference of squares? Why not try the difference of squares method? That's a good question for today. Why not do that? Like, that's so simple. Just make conjugates. Why not? How many terms with every difference of squares question? I'll give you another one. Wasn't this 25x squared minus 4? Isn't that like a difference of squares? How many terms is that? 2. So the only time you'll ever do the difference of squares trick is when you got a quadratic with 2 terms, right? This is a quadratic with 3 terms. Are you with me? And here's our options for this entire chapter. I'm just going to lay it out. It could be a perfect square trinomial, it could be easy factorable, or it could be frowny face factorable. Those are some topics for another day, but today is only perfect square trinomials. So let's see, is this guy a perfect square trinomial? There's a test, right? So is the first term a perfect square? What do you think, yes or no? So let's put his square root right here. Is the last term a perfect square? Not the 49, like the 1 right here. You with me on that? And that's an interesting brain fart that happens to the best of us. Is 1 a perfect square? Yes, it is 1 times 1. Are you with me on that? So that happens to the best of us. What sign do you want, my friends? A plus. But here's the real trick. Is this thing what we want it to be? Is it twice the product of those square roots? The only bad thing about today, because they're all perfect square trinomials, is we're going to get in a bad habit of not checking that last step. It's like, oh yeah, it's totally a perfect square trinomial, because everyone on our homework today is. Wait till the test. Not all of them are perfect square trinomials. But today they are. So let's factor him. Boom, boom, quantity squared. Here's the weird part. He is equal to 49. Awesome. And this is still pretty cool, even though it's weird. would you believe I don't have any p squareds in here anymore? Like, this is just a p to the first power now. And you're starting to learn that one of the best strategies Mr. Fonosfield has shown me is if I have an equation with parentheses, is to just like take a blind eye, please don't cross this out, but take a blind eye to what's in parentheses. Pretend you don't see what's in there. Because to solve, we do the order of operations backwards, and isn't parentheses like the first step in the order of operations? But if we're going backwards, it's the last thing, so I don't want to look in there. If I don't look in there, is that blue thing being squared? And is it all by itself on one side of the equal sign? It sure is. I can get rid of that square then. How can you get rid of the square? We're going to square root both sides. So we'll write it, put the cool square root, put the cool square root. And what happens over here is these bad boys cancel out. Are you with me on that? And what you're left with was whatever was underneath that red blob. I believe it said p plus 1. Is that what it said? So we're left with p plus 1. And over here, here's the hardest part, is when you square root something, algebraically, you get two answers, plus or minus, right? Because the square root of 49 is 7, but isn't it something else? What else could it possibly be? Negative 7, because doesn't negative 7 times negative 7 turn out to be a positive 49? So we'll introduce you maybe for the first time, I don't know, to the plus or minus symbol. That's got a real casual name. That's called plus or minus, because you put a plus or a minus. Now, here's the fun part. Now we get to solve this equation. I try to get p all by itself. There is a plus 1 hanging out with him. How do you get rid of the plus 1? We'll subtract 1, but here's the problem. There's more than one thing over here. There's a 7 and there's a negative 7. So we're going to start it out like this until we get comfortable. We're going to let p plus 1 equal 7, or we're going to let p plus 1 equal negative 7. And I just want to try to overemphasize it early so it's not so strange. You know what that symbol's called? Let me show you. It's called plus or minus. Do you see we took this thing, p plus 1, and set it equal to plus 7, or we set it equal to minus 7. Are you with me? Plus or minus in that case. So let's solve for p. P could equal what on this bad boy? 6, or p could equal negative 8. There's our two answers. Weird, weird, weird stuff, right? Here's the part that people try to change all the time. They start changing these symbols over here. It's like, well, this is p plus 1. I got to do p minus 1. What changed? 7 or negative 7. Are you with me? That was the plus or minus part. Weird. Let's try that again. Did I do something wrong? Okay, sorry. Do you have any questions about that? It's weird. Let's try another one, right? Let's try another. Yes, do you have a question? All right, here we go again. I'm going to talk you through the whole stinking factoring cheat sheet. We're going to like make one later this chapter. The factoring cheat sheet starts like this. Is this equation quadratic? Yes or no? Yep, look for a GCF. That's the first thing you should do. Is there a GCF? This is a 1. We don't care about the equals 64 part. This is a 1. This is a 4. This is a 4. Is there a GCF between any of those? Besides 1, 1 goes into everything. What about 4? Does 4 go into this? Does 4 go into this? Does 4 go into 1? So 4 is not a GCF. This has x's. This has x's. Does this have x's? Not a GCF. Are you with me on that? So phase 1, is there a GCF? No, there is not. The next question you should ask yourself is how many terms does that have? Does it have 2 terms or 3 terms? 3 terms, so difference of squares is out. We will not be doing the difference of squares technique because that involves 2 terms. The only thing we know of so far is it could be a perfect square trinomial. So let's check it out. Is that a perfect square? Yes, it is. We'll put his little square root right there. Then is the last term in that trinomial a perfect square? He's also a plus 4, right? Not a minus 4, so yes, he is, right? So that would be a 2 right here. And then the sign from the middle comes down, and get in the habit of checking, does that blue thing equal twice the product of those guys right there? It sure does. So we will factor him to be this. Then the equal 64 just comes on down for the ride. And what's our move? Ignore you. Don't care about that. isn't there something being squared all by itself on one side of the equal sign if we take a blind eye to what's in the parentheses? So how do you get rid of that square? Square root. So that would be the x plus 2 coming at, sorry, we'll put the square root symbol on both of those. And then here's where, I know we're really good at this, but just double checking. Is it just 8? Square root of 64. What do we need? Plus or minus, right? It's a weird thing to say out loud too. Plus or minus, right? Plus or minus 8. Then we'll set up our two equations. X plus 2 could equal 8, or x plus 2 could equal negative 8. Because that's the name of the game. Plus 8 or minus 8. You know, like plus or minus. Solve both of those scenarios. X could equal 6 or negative 10. We okay with that guy? Nice. Let's rock the old number 12 right here. Definitely a quadratic. Is it got a GCF? I should have said, does it have a GCF? 4, 28, 49. Here's what we're going to do. We're going to cheat code the GCF question because I'm sniffing out that this smells very perfect square trinomially. Because isn't this a perfect square and that a perfect square already? You know, like we have recognition. So here's how I would know if there was a GCF or not, right? I would know when I factor this, if I have to reduce my answer, you know, like then I would have to like factor out a GCF in that situation. So let's try it. Isn't that 2k? Sorry. Isn't that 2k? Because the first guy is a perfect square. And then what would you put over here? 7, and then a plus. Here's what I was trying to say. Look at those two. Between a 2k and a 7, is there a GCF that you could take out of those? So there wasn't a GCF to start with. If it was, say, like a 4k and a 14, would you see that 2 goes into both of those? So it's like, oh, I better have factored out a GCF in that. So it's a little backwards action. And then 2 times 7 is 14. Double that is the 28, and there's the k with it. He is a perfect square trinomial. So I'll let you guys finish that bad boy with a neighbor. We're going to square root both sides because I got this all squared all by himself on one side of the equal sign. I'm going to square root both sides. By golly, stuff has come out nice so far. Don't we get like a plus or minus 5 over there, right? And then we'll set up our two little equations, right? 2k plus 7 equals plus 5, or 2k plus 7 equals minus 5. Just re-emphasizing, this orange thing never changes. It's still 2k plus 7 both times. The only thing that changes is it's 5 or negative 5. 5 or negative 5. So I will subtract 7 from this guy. And that gave me a negative 2. And then I will divide that by 2 to get a negative 1. I will let you do that last one real quick if you still have not. So 2k equals negative 12, and then k would equal negative 6. So two different answers there. Very, very, very weird. How we feeling? It's weird, right? It's going to get weirder. So are we feeling okay with that? How do I know it's going to get weirder? Because look at these. I love you, I love you, I love you. Why do I love those so much? Perfect squares. Don't really care for you, don't really care for you, don't really care for you. Aren't those very different? They are not perfect squares. So now it's going to get even weirder. So hang with me. The real question is this guy over here, since he's got 3 terms and there's no GCF with him, is it a perfect square trinomial? So let's try. Is the first guy a perfect square? Yep. Is the last guy a perfect square? Yeah. And then the sign from the middle sneaks down, and if I did twice the product of those 2 little dogs down there, I do get the 4x that's in the middle. So thumbs up to the perfect square trinomial. So he factors to be x plus 2 quantity squared. Don't know if I've ever told you that. That's how you say parentheses out loud, is the word quantity. So quantity squared, you know. Then over here, it equals 18. The move is the same, right? The move is the same. Don't we have this red blob that we're going to take a blind eye to being squared? How do you get rid of that square? We will square root both sides, right? So I will do this, and I will do this, and that's where you go, this isn't going to come out nice. Here's the rule: no decimals. We are not going to use any decimals, and the blue calculators might have to be taken away for the test again because we are going to have radicals in this answer, right? And we also need to simplify the radicals. So this is going to turn out to be x plus 2, right? And this is going to be plus or minus the square root of 18. And now we have to even pause in the middle of this and say, does the square root of 18 simplify? Is there a perfect square? 1, 4, 9, 16, 25 is too big. Are you with me on that? Is there a perfect square that goes into 18 evenly? Who is it? So we'll just kind of do a little shortcut underneath here, right? We're going to break him down. 9 went in there twice, right? So this is really plus or minus 3 square roots of 2. And then I'm going to bring all the other junk down. So that is sucky that we might have to simplify some radicals. But before we finish this out, do we feel okay with this so far, right? And now, these other ones, I showed you kind of the long way to do it, but it made sense because these were just normal numbers. Like 7, 8, and 5 were normal numbers. Now we have radicals involved with this. So we're going to learn the true algebraic way to finish these off. I would like to get x all by itself. There is a plus 2 hanging out with it. How can I get rid of the plus 2? We are going to subtract 2. So this was what we'll do. We will have a minus 2. Do you see I just subtracted 2 from both sides? Lead off. And then we're going to put plus or minus 3 square roots of 2. Yes, you can use the plus or minus in your lines, right, that you're writing stuff down. And would you believe we have gotten x all by itself, right? By the way, I cannot add those together. Those are not like terms. The negative 2 doesn't have a radical 2 with it. Do you remember last chapter we could add like 4 square roots of 2 plus 2 square roots of 2. Sorry, I was about to say 6 square roots of 2. You could add 4 square roots of 2 plus 2 square roots of 2 and get 6 square roots of 2, because don't both of these have radical 2's with them in that case? This has a radical 2. This does not. So our answer is going to do this. When you have to type this in, you've just got to separate it with the plus or minus. One of them is negative 2 plus 3 square roots of 2. Then the other one is negative 2 minus the 3 square roots of 2. Weird. I got to slow that back down. Do you see I took what's in this green box and wrote the exact same thing both times, except right here I have a plus or I have a minus. Right? You see the 3 in front of the 3 square roots of 2 is where the plus or minus is. So it's negative 2 plus 3 square roots of 2, or it's negative 2 minus 3 square roots of 2. There's your 2 different answers, and that's how you got to type it into the computer. Whew! We might need to do another example like that, right? So let's try another weird one. First, let's start with this. Is this a perfect square trinomial? Work with that on a neighbor. If it is, factor it. W, 5, and who's the symbol in the middle? We haven't had very many of these. Who's the symbol in the middle? Minus. And yes, that's twice the old product over there. But it's going to equal 3, right? So here's what I would like to mention. This can be very overwhelming if you're looking at one long problem. It's a lot of work. It's a lot of steps. We're going in phases. Phase 1. How did you feel about factoring that perfect square trinomial? I think we're feeling pretty good with that, right? Phase 2. Get rid of that square. How do you get rid of that square? Square root both sides. Ba-boom, ba-boom. Not going to come out nice. Would you agree? Not going to come out nice. But over here, it's w minus 5. and that will equal plus or minus the square root of 3. To be quite honest with you, this is a billion times nicer than the previous one, because does the square root of 3 simplify? There is no perfect square that goes into 3 evenly besides 1, so I don't have to do that extra move, right? So that's nice. Then what do I do next? Get rid of this minus 5. I want to get w all by itself, so how do you get rid of a minus 5? Plus 5. Please put it first. Do not put plus or minus the square root of 3 plus 5. That just looks weird. The plus or minus needs to be in the middle of those things, right? So normal number first, plus or minus square root of 3 last. Please just believe in my math experience that that other thing looked really weird. They both look weird, but it's like that other thing is even stranger. How many answers are here, my friends? That's my question. How many answers are there? Is that just one answer or is that 2 answers? That's 2. Are those like terms? 5 and a square root of 3? Are they like terms? Nope. So we just separate them out. One of them is 5 plus the square root of 3. The other one is 5 minus the square root of 3. Do you see the plus or minus in that scenario, right? The plus or minus. Cool. It's okay if we're not liking it. Are we feeling okay with what we're trying to do, though? Nice. We'll get to the danger zone. Let's go to the last one. Please factor that perfect square trinomial. I'm going to put this in a new window. That lets you know there's lots of work on this one. Oh, man. It didn't go in a new window because I didn't check that box. Do you also think it's interesting how I know which ones are going to be harder and harder and harder, besides the fact that I'm the teacher? But I can just look at these and go, ooh, this is going to suck. Can anybody tell me what is really different about this one compared to the last ones? It's okay if you don't know. Anybody see something? It's that. You know, you didn't get a 1 in front of there, right? Didn't you have like a 5 or something like that? So that's going to make another weirdo step. But are we cool with this, right? All right. What's my next move? What do I do next? Square root both sides. All right, let's square root both sides. So ba-boom, ba-boom. Plus or minus the square root of 75. Crap. That's a big boy. He probably simplifies. It ain't our first rodeo, but we're still new to the rodeo. 75 is a pretty cool number, though. What perfect square goes into 75 evenly? 25. So you can just do that right underneath there. 25 goes in there 3 times. Isn't that really plus or minus 5 square roots of 3? Bring everything else down. What an ugly scenario. I didn't even notice this. Look at how many 5s and 3s are in this problem. You know, that's weird. All right. When you have a radical involved, like there is totally a radical in this answer, we're just going to try to get this x by itself. What's our move? Get rid of that plus 3. How do you get rid of that plus 3? We will subtract 3. So 5x is here, and that will equal negative 3 plus or minus 5 square roots of 3. In all seriousness, of all the work we do, this is probably the most missed part. You have to move this to the other side by doing the opposite. It is amazing how that one little sign error is such a simple thing, but we're so concentrated on everything else, we forget about that guy. Cool? What's left? X is not by itself. What's left? Divide by 5. And we're going to make it simple. I'm going to show the baby step like way back in the day. We are going to divide this by 5, and we divide that whole mamma jamma by 5. So those will divide out to be 1, right? And we are left with x. And we are going to make our answer look like this. We're not going to try to separate it out. We're just going to leave it like so. But how many answers are there in that when there's a plus or minus? Is that a 1 or a 2? That's 2. So here's what we'll do. We're going to write this down twice. One time it will have a plus in that spot. The other time it will have a minus in that spot. Everything else stays the same. Negative 3 plus 5 square roots of 3 all over 5. Or negative 3 minus 5 square roots of 3 all over 5. Those two homeboys are literally the same thing, except for one of them is a plus, The other one is a minus. That's the plus or minus. And I know it has been a long day. I can see some people's brains pondering this. Can we reduce that? And welcome to the new thing called the triangle of death. I made that phrase up. Most of this stuff I made up the phrases. The triangle of death means this. If you have two terms up in a numerator and one in the denominator, to see if things reduce, you have to look at all three of them. Right? 5 goes into him. 5 goes into him. Does 5 go into him? So that's why I call it the triangle of death, is people start trying to reduce 2/3 of that thing. You got to reduce all three of the things if that really is happening. Woo! What a long one. Here's what we need. Some practice. So let's do some homework with these guys, right? You will definitely need to write some stuff down today, right? So we'll do a little bit of writing down. Not every one of them needs work shown. You'll figure out when you do or not. You'll figure out when you do. There might be some where you got to take a GCF out first too, right? Not very many, but maybe just one or two. It's like, oh God, I got to take a GCF out before I start. Look out for that.